Welcome to question 6 of the 2010 Mathematical Methods Exam 1. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. So for question 6 we're told that the transformation T maps from R2 to R2, which just means that we're on a Cartesian plane, and it's defined by the following matrix equation. And the image of the curve y equals 2x squared plus 1 undergoes the transformation T, and that gives an equation in the form y equals ax squared plus bx plus c. And we're asked to find the values of a, b and c. So the first thing that we actually need to do is multiply out that matrix equation. So this t of x, y just here, I'm going to rewrite that as just being x dash and y dash. And that's going to equal something on the right hand side once we're finished multiplying out and evaluating that matrix system. So when we multiply matrices, we take a row from the first matrix and we multiply it by the column of the second matrix. So when we do that, we get 3 times x, so we get 3x plus 0y, so I'm not going to write that there. And then from the next matrix we're going to add on -1, so that's just going to be subtract 1 in that position. We'll then perform the next multiplication, so we take the next row and multiply it by the column of the second matrix, so we get 0x and then 2y, so we're just going to write 2y, and then we're going to still add on 4, so we're going to have plus 4 in this position. So that is now what the matrix on the right hand side is equal to once we've evaluated it, and that means we can write two things. So we can say that x dash must equal 3x subtract 1, and we also know that y dash must equal 2y plus 4. So our next job is to rearrange so that we get the x and the y terms without the dashes by themselves. So for the first equation involving x, we can start by adding 1 to both sides. So therefore we get x dash plus 1 is equal to 3x. And then dividing both sides by 3, we'll get x by itself. And we get that x is equal to x dash plus 1, all divided by 3. Now we do the same thing for the equation involving y, so we're going to start by subtracting 4 from both sides. So therefore we get y dash take 4 is equal to 2y, and then to get y by itself we need to divide both sides of the equation by 2. So therefore we find that y is equal to y dash take 4 all divided by 2. Next up we're going to substitute what we just found into the original equation, which was y equals 2x squared plus 1. So that's the equation that's undergoing the transformation. So therefore, wherever there's a y, so in the case of y equals, we're going to replace it with y dash take 4 over 2. So we're going to have y dash take 4 all divided by 2 is equal to 2. But wherever there's an x, we're going to replace it with x dash plus 1 divided by 3. So we're going to have x dash plus 1 divided by 3 all squared. And then there's still a plus 1 in that position. From this line to our next line, we're going to multiply by 2. So that will get rid of this term here. And all terms on the right hand side will be multiplied by 2. So therefore we have y, and I'm now going to call it y1 and leave off the dashes. So I'm going to have y1 subtract 4 is equal to 2 times 2 is 4. And then these brackets I'm going to square. So on the top line I'm going to get x squared plus 2x plus 1. So that's a binomial expansion, so don't forget that there's 3 terms that come out of that. And then on the bottom line, dividing by 3 squared is dividing by 9. And then we still have a plus 1 here, but we multiplied that by 2, so we can't forget to do that, so that's now plus 2. So now we just need to do a little bit more algebraic simplification. So from here to our next line, I'm going to also add 4 to get y by itself. So therefore, we get y1 is equal to, and now we have 4x squared over 9, so 4x squared over 9, so we're expanding this bracket out. And we get 4 times 2x is 8x, so you get plus 8x over 9. And then we have 4 times 1 is plus 4 over 9. And then we've still got plus 2 plus 4 is plus 6. But I'm going to write that plus 6 as being plus 54 over 9 so that we've got a common denominator. So therefore, y1 must equal 4 over 9 x squared plus 8 over 9x plus 58 over 9. However, this question asks to find the values of a, b and c. So we can write that a must equal the coefficient of x squared, which is 4 over 9. B must equal the coefficient of x, which is 8 over 9. And C must equal the constant term, which is 58 over 9. So that is the answer to this question. So in the examiner's report, we can see that nearly a quarter of students got full marks for this question, with a majority of students only getting 0 or 1 mark. So it wasn't particularly well done during this exam. The examiners noted that there were 3 different approaches taken to this question, and that the method that we did on the previous slide was the most effective approach. So students who attempted to define the transformations based on the matrices often misinterpreted both the dilations and the horizontal translation, and then did not rearrange to construct a new rule, so they would have achieved very few marks in this question. The other method, for the students who chose to determine the inverse matrix, often made errors in their inverses and or the multiplication of the matrices, so it was much safer just to evaluate the matrix and then plug those new values for x and y into the old equation.